Hello again, everyone. In today's lecture, we will continue with the important terminologies, important terms that you need to understand. And before you start with the actual programming, before you start with the actual query in your database, you need to know few of the important and few of the commonly used terms. And you need to understand those concepts so that it becomes easy for you when you actually start with the actual query language. So we'll start with the first one. The first terminology here is the entity. Fine, this is the very first concept that you need to know in order for you to create a database. Now, to create a database, what you need to know is you need to first understand what are the things that you want to put into your database. What are the concepts that you actually want to create? For example, if you want to create a database for a college, fine. So what you need to know is you need to understand that in order for a college to run, you need a student, right? You need teachers, you need the different departments, you need books, you need staff. Those are few of the examples. So in this particular case, those things that actually makes your database function, and those are the things that actually will bring down your database. Those can be referred to as an entity. For example, a student, a department, a teacher. Right. So when we talk about an entity, I've also mentioned this point that data that you feed or you store into the database have to be something that exists in the real world. Right? You cannot just assume things when you are actually designing, when you're writing an actual database. Because of that, the object that you'll have to put here have to be an object that really exists in the real world. So entity here can be any object or thing in a real world. This object can have a physical existence. I mean, you can see them, you can touch them. For example, like a student, a teacher, in this case, car, a person, a house, or it can only have a conceptual existence. You don't see it, but conceptually it exists, like a department. You don't actually see a department, but you know that it exists. The concept of a department exists. I mean, the idea of a department exists. Other than that, you have a company job, you have a university course, right? Those are the conceptual entity. So entity here can be either a physical entity or it can be a conceptual entity. Now this entity here in a database, the entities table, I have already mentioned that your relational database can be written down in the form of rows and column, right? Combination of rows and column. So once you write it in the form of rows and column, you can refer to that as a table. Now this entities table, I say for example a student, entity student, if I maintain a table for that table, that student's table here will be referred to as a relation or a table. So the entities table here will be referred to as a relation or a table. Example here, we have entity students, right? So the student here, I'm talking about the student's detail. There's another entity teacher here, and here I'm talking about the teacher details. So in this particular case, when what happened, this particular student details comprises of rows and column. Fine. Now this student details here can be referred to as a relation. So the relation here, this entire table can be referred to as a relation or table. So it's a student's relation or teacher's relation here. So that is what a relation is all about. Fine, you have an entity and the table that you maintain for that particular entity. You have a student as an entity here and you maintain a table for the entire details of this particular entity. This table here can be referred to as a relation. Right, so those are the details that actually that is mentioned for each and every details here. Okay, we'll proceed to the next one here. We have a tuple. Now in a table you have both rows and column, right? The rows or the horizontal subset that we call here of a particular table represents what we call as the concept tuple or record. Fine, a row. Okay, you think about a row here. For example, if you go back to the previous one, what do we have here? We have a row here, say Mary, 1, 2, 3, 4 is the row number and commas. When we talk about this particular row, one single row here, fine, one single row talks about one actual person, fine. And then the second row here, John, and then John's row number and John's department. So each and every row here maintain the records of exactly one person. This row here, Mary's roll number and Mary's department. We are talking here about the record of Mary's detail. Likewise, Professor say B, ID number 1890 and commerce. This here one particular row speaks about one particular person records. That means this particular case Professor B's record or Professor B details. Fine. So that is what you have here. The tuple is also known as a record. Fine, we are talking about a record of that one individual person, which gives the particular information of the relation. It gives about a particular information. It talks about particular specific details of a particular relation. Fine. For example, here, like what I've already mentioned, when we talk about Mary, here it's the student's name is Mary, student roll number is this much, and then Mary's department is commerce. Here we are talking about the details of one exact person. Fine. So one row here will give you the record of one exact person. That is what we call this here, the tuple or the record. Fine. So every row here represents one tuple. Fine. Every row represents one tuple. So here professors A, here this particular row represents the details of professors A. This second row here maintains the details of professors B. This here is just the heading. Fine, heading of this title. Next one is the attribute. Likewise, what you have is we already talked about one single row. Now here we are referring to one specific column. Right, we are referring to one specific column here. Let's take this column here. S underscore name I've mentioned for student name. This here, this one column here maintains the talks about the this particular details, the name of a student. Fine. So here all this list now will be referring to name of the various students. Then likewise, this particular column here talks about the roll number of every student they enroll in a college. This particular column here talks about the department. Now this column that you have here, student name, roll number and department, these are referred to as an attributes. Fine, it is referred to as an attributes. So the column or the vertical subset of a table here represents an attribute. Attribute here you can mention this, you can define this as the properties that describe a relation or an entity. When you talk about an entity, say student. Fine. Then what do you mean by student? If you refer to the attribute, this means the student name. This means just roll number will have no meaning, right? So it is student's roll number. Just by department, it have no meaning. But it is the department where a student is enrolled. That is the meaning of an attribute. And it defines the properties of every attribute. So you have an attribute teacher underscore name, but you need to have some name, right, for that. So those here will be specified by Professor A and Professor B. So attribute here is the properties, like what you have in case of say your adjective. Fine. Attribute here can be considered as an adjective. Right? Just having a noun is not sufficient. In order to properly to express more about a noun, say a car. What type of car are we talking here? Fine. So in order to make it more specific, you assign the attributes to that particular entity. So it's not just, we are not talking about just a student, but we are talking about a student name. We are not talking just about any roll number, any random roll number, but we are talking about a student's roll number. So when you assign attributes to any of the entity, right, it becomes more clear, right, against what we are talking about. So that is why attribute here can be referred to as the properties that describe a relation or an entity here. Every attribute here will be assigned with a value. Say for example, you have given s underscore name, right? In the table, if you go back to the previous table, we have given s underscore name as an entity. Fine, as an attribute, sorry. Now to this attribute, I need to assign a name. What name should I give? Mary. If I give, say, department name here, department name is an attribute. If I just call department name, it will have no meaning. Fine. I mean, the meaning will not be fulfilled. So, but I mention it as arts or commerce department name. Fine, then it becomes meaningful. So this is the meaning of attributes. Say a student name or a department name equal to followed by the value. Value here, if it's a department name, will be arts or commerce. Example here that I've given is s underscore name. Student underscore name is an attribute. Now what value do I want to assign to this? I will assign the name Mary. And this is the meaning of that. Next one is the domain. See here, for every values that I have assigned, fine, there have to be some sets of possible values, right? You cannot just assign randomly anything. If I mention, say for example, let me start with example, gender. To gender, you can give either male or female. Okay, I forgot to mention one here, or others. Fine. For example, for gender, there are only three possible values. Fine, please add that up. It will be either male or female or others. Right, now these are the only three possible value for gender. Right, so if I talk about the date, there have to be only one accepted value where you have date, month and year. Fine. If I consider, say for example, binary number. Binary number, what are the possible values? There will be only two possible values for a binary number, 1 and zeros. So that list of possibility that you can use while assigning value, fine, to your attribute is referred to as a domain. The domain here describes the set of possible values for a given attribute. So those possible value can be either an integer. If I ask you what is your age here have to be a number, right? It cannot be a name, it cannot be an alphabet. Right? So the possible value for that will always be an integer or a number. And then you have a domain as character, as a date, as time, as a boolean value. Boolean value means 0 and 1 combination. A domain here is the original sets of atomic value. When I say atomic value, that means this cannot be divided any further. If I say gender equal to male, you cannot more like divide male. Whereas if you say date of birth here I can divide it into date, month and year. Right? So that is not atomic. When I say only date, say if I mention that today's date is the 16th of October, or if I just mention the exact date, so it is 16. So this 16 I cannot divide it any further. If I mention that the month is October, I cannot divide month any further. So this is the meaning of an atomic value. Find a value that you cannot subdivide it any further. You cannot divide it anymore. Domain here is a set of acceptable values. So the domain, the value that you'll feed in have to be a set of only acceptable values. You cannot just feed any value. So same like with example, gender here will be either male or female or others. So those are the only possible and accepted value. You cannot feed any other value to a gender. And that is the meaning of a domain. Now in your database management system, when you'll start using query, you'll have to find relation. Fine, you have to make your table very, very strong so that your table have its own identification. So that is what your key will be doing here. Keys here are an important part of your relational database, and it acts also as a vital part of the structure of a table. And because what happens here is when you have a key here, key will maintain the integrity and help to identify the relationship between tables. See here in a database is not just one table. Database is a collection of tables. Now in order for you to connect one table to another table, there have to be some link, right, between one table and another table. Fine. So in order to form this link, you need to have this key, which we will discuss in the next lecture. You need to have all these keys. Say for example, if I talk about this table, now how will I link this? I cannot use the student name exists only here. I cannot use the roll number exists only here, table, teacher's name and ID name. But what we have is, we have something common here like a department name and a department name. So this here acts as a link. Right? This acts as a link between these two tables. This is how I can connect the student's detail and the teacher's detail because they both belong to say the same department. Right? So that is what a key is all about. There are 4 different types of keys that we will discuss: the candidate key, primary key, foreign key, and the alternate keys. In the next lecture, we'll discuss in details about this. Find all the 4 different types of key. So we'll stop here for today. Thank you very much.